Hi, myself Lawrence. Now I am going to give you a short brief about the chip multiprocess. In these there are four categories. One is rational behind CMP, the second one is core multithreading, and the third one is chip multiprocessor architecture, and the fourth one is programming models. Now I am going to give you a short introduction about the chip multiprocessors. There are different types of microprocessors which are homogeneous, heterogeneous, and conjoined core processors. These above processors are addressed and briefly described with the new trends and programming models in this section. At the same time, we will describe multi-threading cores in this section to provide a clear understanding of the subject. Now we will move to the rationale behind chip multiprocessor technological trends. In the market, cost factors and yields are becoming one of the best trends rather than the technological factors. Most of the markets wants the simple as well as effective devices at the same time. Nowadays, the main focus is on the processor designing. Process of technology is the making of processors are very old, but the changes in the design have occurred a lot in the making of multi-core processor. In these days, minimizing the cost and maximizing the yield is the best focus in the processor making because the cost is a great factor like yield. Adopting CMOS technique for processing is the best tradition. In this conjoined core processor making, silicon CMOS is the preferred technique for the processing. Now we'll move to the core multi-threading software. In this there are four categories, and the first one is software supported multi-threading. Software support multi-threading helps in using various parts of a program at the same time by various programs. With the help of software support multi-threading, it gives more effectiveness and efficiency in the processing. Due to software support multi-threading, complexities and concurrency complication of softwares will arise as well. Here, there is an advantage of parallelism. Using parallelism, performance of the software will be increases. At the same time, it improves the processing time in the smaller spaces. Now, we will move to the hardware supported multi-threading. In this, two different systems can use the same hardware for the processing of applications. With the hardware supported multi-threading, it improves space management and time management as well as resources. Coarse grained and fine grained multi-threading are the simple type of hardware multi-threading. Coarse grained multi-threading runs until it gets blocked by an event. Then a programmer needs to switch it to another file for the processing continuation. Fine grained multi-threading. In this process, every cycle of the CPU checked by the hardware for continuations. Multi-threaded MIPS CPUs are designed to be as per their effectiveness and efficiencies with the demand of customers. Now we will move to the block or coarse grain multi-threading. In this multi-threading, one work continues until a long latency stalls occurs for blocking. It does stops until the blocking reason solves. Despite that, it starts to process in another route for faster execution of the process. In order to do that, hardware is installed in the CPU for that purpose. Various microcontroller families are embedded, and with the help of switching context, multiple banks of registers interrupt the processing. Performance improvement gains in this model for thread switching phenomenon of this multi-threading, and as most of the work done in the cycle of CPU, it improves the efficiency as well. Every active set has their own register set, which is very costly. Now we will move to the interlevel fine grain multithreading. Removing all types of data dependency stalls are the main aims of this multithreading technique. As in the multithreading technique, all the threads are mostly independent. It improves the effectiveness and efficiencies as other threads do not bother about output of other threads. It was the first introduced as barrel multithreading because of steps. Those are introduced in the pipeline stages of their executing stages. Resources and chances need to be bigger too in these techniques in order to maintain the wastages in various threads for minimizing or minimum thrashing. Now we'll move to the simultaneous multithreading processors. In this multithreading processor, all the threads will be used to process and to recognize each other. In this simultaneous multithreading processor, instruction level parallelism technique has been implemented to improve the functionalities of the threads. As per the programming of the threads needed at the beginning of the process, it is very costly. However, for the maximum effectiveness output, providing ability cost is not that much of a problem for this multithreading. This is the end of my part. Now the next slides will be continued by Akhil.
Hi everyone, myself Akhil. I am gonna explain you about chip multiplexing in homogeneous. Homogeneous denoting a process involving substances in the same phases. In this CMP architecture, one type of processor is implemented over and over to gain various types of functionalities as well as various results at the same time. In this homogeneous, most of the time, 8 Ls of processors are linked on the shape to make these types of architecture. DNP interface and external RAM putting features are also available in this course, which are highly beneficial and effective for better and outsourced processing. I'm going to explain you about the CMPs with heterogeneous cores. Heterogeneous denoting a process involving substances in the different phases. In these CMPs, various types of processors are used for various types of functions. Different type of processors are need to implement with each other. Developers and programmers needs to acknowledge every specification of those processors. This types of cores is very tough as the different functions are present in the processor. In this, all the process works independently. It does not stop dealing this process to have an outcome from the another processor. The next one is conjoined cores. In conjoined multiprocessor, consider with 4 optimization instructions. One is cache sharing, data cache sharing, FPU sharing, and crossburst sharing. For each kind of sharing, 2 adjacent cores share the hardware structure. This type of cores are mainly made in this multiprocessor architecture. These caches and resources used by both processors in the architecture, which improves its effectiveness and waste management at the same time. As shown in the figure, 2 different types of processors are used. Performance degradation can be a great problem for these types of cores. Thank you. Next slide will be continued by the Rahul Reddy.
Hi everyone, myself Rahul Reddy. I'm going to explain the last session of the presentation. My presentation is about programming models. There are 5 types of programming models. They are interdependent processes, transactional memory, thread level speculation, helper threads, redundant execution to improve the reliability. Coming to the interdependent processes. In interdependent process, we investigate how multiple actors accomplish interdependent routine performances directed to a novel intended outcomes and how this affects routine dynamics over time. We identify 3 types of routine works. They are flexing, stretching, inventing. It is essential to improve the interdependencies of the system for better resources and wastage uses of a programming model that will improve its effectiveness and time management. This interdependent process reduces the time management of the system as a program needs to wait for the outcome of another process. Coming to the next process, transactional memory. In transactional memory, it attempts to simplify concurrent programming by allowing a group of load and store instructions to execute in an automatic way. This transactional memory has a multiple transactions happened at the parallel system which needs to have permission for committing. Coming to the thread level speculation. Thread level speculation. In this multi-threading processor, indicated by the thread level speculation in a processor. It is one of the best research topic because it enhances energy efficient processor which are very crucial for more effectiveness and efficiencies. This energy consumption can be avoided only with the help of thread level speculation. Coming to the next topic, helper threads. In helper threads, it executes an application that helps in data bringing and catchy miss possibilities. Helper threads improves time management in a processor and also help the processor in dictating errors in the system. With the VMT approaches, helper threads can be launched which responses in the long latency for quicker responses of the system. Coming to the redundant execution to improve the reliability. Redundant execution is essential for transmitting tolerances in a system and improves the system by introducing a voltage and frequencies in the system, which helps to have a dissipation of power. This power in a system really essential for better development of future system. Now I am gonna give conclusion of the presentation. From the above discussion, it concludes with multi-threading and different architectures. It helps in the effectiveness of efficiencies of a processor can improve a lot. Homogeneous and heterogeneous as well as conjoined causes architecture are very useful in the CMOS techniques, which is one of the main trends in electronic market nowadays. Thank you.